The sulfate process produces wood pulp which is almost pure cellulose fibers by using various salts of sulfurous acid to extract the lignin from wood chips in large pressure vessels called digesters. The salts used in the pulping process are either sulfites, or bisulfites, depending on the pH. The counter-ion can be sodium, calcium, potassium, magnesium or ammonium. History: the use of wood to make pulp for paper began with the development of mechanical pulping in Germany by F. G. Keller in the 1840s. Chemical processes quickly followed, first with J. Rath's use of sulfurous acid to treat wood, followed by Benjamin Schutt-Hildmann's U.S. patent on the use of calcium bisulfite, Ca. HSO3, 2, to pulp wood in 1867. Almost a decade later in 1874 the first commercial sulfate process sulfate pulp mill was built in Sweden. It used magnesium as the counter-ion and was based on work by Carl Daniel Ekman. By 1900 sulfate pulping had become the dominant means of producing wood pulp, surpassing mechanical pulping methods. The competing chemical pulping process, the sulfate or kraft process, was developed by Carl F. Dahl in 1879 and the first kraft mills started in 1890. The first sulfite mill in the United States was the Richmond Paper Company in Rumford, Rhode Island in the mid-1880s. The invention of the recovery boiler by G. H. Tomlinson in the early 1930s allowed kraft mills to recycle almost all of their pulping chemicals. This, along with the ability of the kraft process to accept a wider variety of types of wood and produce stronger fibers, made the kraft process the dominant pulping process starting in the 1940s. Sulfate pulps now account for less than 10% of the total chemical pulp production and the number of sulfate mills continues to decrease. Magnesium was the standard counter-ion until calcium replaced it in the 1950s. Processes involved in sulfate pulping. Pulping liquor preparation The pulping liquor for most sulfate mills is made by burning sulfur with the correct amount of oxygen to give sulfur dioxide, which is then absorbed into water to give sulfurous acid. S plus O2 or SO2, SO2 plus H2O H2SO3. Care must be taken to avoid the formation of sulfur trioxide since it gives undesired sulfuric acid when it is dissolved in water. 2SO2 plus O2 or 2SO3, SO3 plus H2O H2SO4. Sulfuric acid is undesirable since it promotes hydrolysis of cellulose without contributing to delignification. The cooking liquor is prepared by adding the counter-ions as hydroxides or carbonates. The relative amounts of each species present in the liquid depend largely on the relative amounts of sulfurous used. For monovalent hydroxides, MOH, H2SO3 plus MOH or MHSO3 plus H2O, MHSO3 plus MOH M2SO3 plus H2O, for divalent carbonates, MCO3, MCO3 plus 2 hours 2SO3 AM, HSO3, 2 plus CO2 plus H2O, M, HSO3, 2 plus MCO3 or 2 MSO3 plus CO2 plus H2O. Pulping Sulfate pulping is carried out between penthouse 100 and 5, depending on the counter-ion to sulfate and the ratio of base to sulfurous acid. The pulp is in contact with the pulping chemicals for 4 to 14 hours and at temperatures ranging from 130 to 160 degrees Celsius, again depending on the chemicals used. Most of the intermediates involved in delignification in sulfate pulping are resonance-stabilized carbocations formed either by protonation of carbon-carbon double bonds or acidic cleavage of ether bonds which connect many of the constituents of lignin. It is the latter reaction which is responsible for most lignin degradation in the sulfate process. The electrophilic carbocations react with bisulfite ions to give sulfonates. ROR plus H plus A plus plus Rho, R plus plus HSO3A RSO3 hours. The sulfate process does not degrade lignin to the same extent that the kraft process does, and the lignosulfonates from the sulfate process are useful byproducts. Chemical recovery The spent cooking liquor from sulfate pulping is usually called brown liquor, but the terms red liquor, thick liquor and sulfate liquor are also used. Pulp washers, using countercurrent flow, remove the spent cooking chemicals and degraded lignin and hemicellulose. The extracted brown liquor is concentrated, in multiple effective evaporators. The concentrated brown liquor can be burned in the recovery boiler to generate steam and recover the inorganic chemicals for reuse in the pulping process, or it can be neutralized to recover the useful byproducts of pulping. Recent developments in Kimrex black liquor gasification process, adapting the technology to use in the sulfate pulping process, could make second-generation biofuels production an alternative to the conventional recovery boiler technology. The sulfate process can use calcium, ammonium, magnesium or sodium as a base. Calcium-based, the earliest process used calcium, obtained as inexpensive calcium carbonate, and there was little incentive to recover the inorganic materials. Ammonia-based processes do not allow recovery of the pulping chemicals since ammonia or ammonium salts are oxidized to nitrogen and nitrogen oxides when burned. Magnesium-based, the recovery process used in magnesium-based sulfate pulping, the magnetite process, is well developed. The concentrated brown liquor is burned in a recovery boiler, producing magnesium oxide and sulfur dioxide, both of which are recovered from the flue gases. Magnesium oxide is recovered in a wet scrubber to give a slurry of magnesium hydroxide. MgO plus H2O Mg, OH, this magnesium hydroxide slurry is then used in another scrubber to absorb sulfur dioxide from the flue gases, producing a magnesium bisulfite solution that is clarified, filtered and used as the pulping liquor. Mg, OH, 2 plus 2SO2 Mg, HSO3, 2. Sodium-based processes use a recovery system similar to that used in the Kraft recovery process, except that there is no lime cycle. Applications: the sulfate process is acidic, and one of the drawbacks is that the acidic conditions hydrolyze some of the cellulose, which means that sulfate pulp fibers are not as strong as Kraft pulp fibers. The yield of pulp is higher than for Kraft pulping, and sulfate pulp is easier to bleach. Commodity: sulfate pulp remains an important commodity, especially for specialty papers and as a source of cellulose for non-paper applications. It is used to make fine paper, tissue, glassine and to add strength to newsprint. Dissolving pulp: a special grade of bleached sulfate pulp is known as dissolving pulp, which is the raw material for a wide variety of cellulose derivatives, for example rayon, cellophane, cellulose acetate and methyl cellulose. Rayon is a reconstituted cellulose fiber used to make many fabrics. Cellophane is a clear reconstituted cellulose film used in wrapping and windows and envelopes. Cellulose acetate was used to make flexible films for photographic use, computer tapes and so on, and also to make fibers. Methyl cellulose and other cellulose ether derivatives are used in a wide range of everyday products, from adhesives to baked goods to pharmaceuticals. Byproducts: sulfate pulping is generally less destructive than Kraft pulping, so there are more usable byproducts. Lignosulfonates: chief among sulfate process byproducts are lignosulfonates, which find a wide variety of uses, whereas relatively inexpensive agent is needed to make a water dispersion of a water-insoluble material. Lignosulfonates are used in tanning leather, making concrete, drilling mud, drywall and so on. Oxidation of lignosulfonates was used to produce vanillin, and this process is still used by one supplier, while all North American production by this route ceased in the 1990s. Other byproducts: acid hydrolysis of cellulose during sulfate pulping produces monosaccharides, predominantly mannose, which can be fermented to produce ethanol. See also, Kraft process, pulp mill, wood pulp, bleaching of wood pulp, paper, pulp and paper chemicals. References: ABCD East Jar Paragraphs to Paragraph M. Wood Chemistry, Fundamentals and Applications. Academic Press. ISBN 0-12-647480-X. ABCD by Ehrman, Christopher J. Essentials of Pulping and Paper Making. San Diego, Academic Press, Incorporated. ISBN 0-12-097360-X. History of Paper. Retrieved October 8, 2007. Swedish, German mills phase out sulfate. Pulp and Paper. January 1997. Retrieved October 8, 2007. Wisconsin sulfate mill shuts down 2005 inches. Retrieved October 7, 2007. Friedrich, Stephen. Living on Borrowed Time Its Whole Life. The Daily World. Retrieved October 8, 2007. Kimrec website, Magnafite process. Retrieved October 11, 2007. Grades and uses of paper. Retrieved October 12, 2007. Dissolving pulp by the sulfate process. Retrieved October 12, 2007. Applications for methosyl cellulose ethers from Dow Chemical. Retrieved October 12, 2007. Uses of lignosulfonates. Retrieved October 7, 2007. Hocking, Martin B. Vanillin, synthetic flavoring from spent sulfate liquor. Journal of Chemical Education 74, 1055. Bibcode, 1997 JCH ed 74.1055H doi, 10.1021/ed 074p 1055. Retrieved September 9, 2006.